Alrighty. Thank you guys for making it. I know it's 4:15. It's late in the afternoon. It's been a busy day. If your day is anything like mine, it's probably back to back to back. So I'm going to try to pace this entire stage because the lights are like glaring in my face, and I'm going to look to the sides most of the time because I can't see anything over here. Anyway, thanks a lot. The session is pretty straightforward. It's titled about how our customers are modernizing using our database services. Today we have two great customers from, or the CEO of a great customer and Dennis from Fidelity to talk about how they're using DynamoDB to modernize and run their operations. That in itself is a pretty common discussion point. Most of the customer conversations that I have, and frankly, over time and at the show, have really been around modernizing what customers are doing or how they're trying to do that with our purpose-built databases. And so this resonates. It's very key to their success. It's key to their business. It's key for them in staying in business. And so the fact that you guys are here tells me that this is important to you as well. And so I'm glad that you guys are going to listen to our show. All right, Vladimir Konevsky. I've been at AWS for about 4.5 years. I'm a principal go-to-market specialist on our NoSQL database services. I'll let Dennis and Manish introduce themselves. When they step up, I'll go through a little bit of an overview of what and how our databases are helping customers modernize and why they're doing it. And then we'll introduce Dennis to talk about how he's using Dynamo at Fidelity, and Manish will close it out and how he's using it at Reltio. All right, well, let's start here. This is a pretty common quote. It's actually from 2019, but it probably resonates with most of you. All right, it says that CIOs are spending 80% of their developers' time managing infrastructure as opposed to innovating and building applications. And so this is a pretty straightforward statement, but the underlying issue there is that these technical or developer issues and challenges are actually preventing these customers from innovating and actually modernizing their business and becoming more efficient and enabling them to actually respond to their customer needs, to what they're trying to do, to address their business needs more quickly. And so this is not just, hey, we want to go digital. It's really about how do we enable you guys as customers to be able to do that successfully? Because frankly, not a lot of folks have done it. And by the way, I want to say I had 7 meetings yesterday, and I think every one of those customers was in the same position. Hey, we've been trying to do this for years. We've been talking about going digital. We've been trying to do this, successfully, and it hasn't happened. So anything we can do to help is key, and that's why this session is important. All right, we talk about the ability to be able to respond to customers' needs, to be able to become more efficient, to build applications that can respond not only to new businesses, new concepts, new business models in general. And if you can't, most of the time, many times, you're either going to be out of business relatively soon and are not going to be able to participate in a new market. And so there's a huge impact to the organization, the company, the business unit, if you're not able to just innovate on the fly, respond to customers, and reduce the latency, increase efficiencies, both on the operational side, but on the business and actual technology side as well. You can't build apps quickly. You can't launch and go to market quickly. Your release times are a lot longer, and obviously that impacts your ability to respond, right? This is not new. I think you guys have seen most of these slides already from other speakers, so I'm trying to gloss it over and say them in a different way. But if you're not, in essence, if you're not building a data platform or an application modernization platform that enables you to, let's just say, respond to net new business models. For example, we all buy things faster. We have apps that bring things and deliver to us. We stream videos now. We expect zero latency, almost real-time response from any click that we do. That didn't exist even a few years ago. And so if you're still using legacy infrastructure to not only databases, but infrastructure, development protocols, you're not able to actually build applications that do that. So we did this years back, and we had to respond to the same issues as you guys are, most of our customers are running into today. I mean, sort of the laws of large numbers accelerated all this for us. So back in 2004, we were running into the same issues. We had a bunch of legacy infrastructure. We had a lot of relational databases. When I say a lot, thousands and thousands of relational databases that were running our business. So all of the commerce business, so the websites, ordering systems, the payment systems, tracking systems, everything was running on a relational database. And we had, let's just say, thousands of them, right? I think the official number is like 75,000, or 7,500, sorry. That said, it took us months to scale because we needed a plan for, let's just say, Cyber Monday or Black Friday like we had this week. We needed to scale immediately, and we couldn't, right? It took us months and hundreds of man hours to be able to just build out the capacity or plan out the capacity that we needed to do for that one day, right? It took us months and again, hundreds of man hours to be able to build infrastructure to be able to support that business, and then carry a whole inventory of spare parts to be able to break stuff or fix stuff when it breaks, right? And so we stepped back, we analyzed how and what data we're accessing and when, and we realized that we just needed a whole new data platform to be able to respond to our business. Dynamo paper was an outcome of that. I don't know if anybody has read that, but that Dynamo paper basically summarized the fact that only 10% of all of our data was needed to have a relational attribute to it. So 70% were a single key, another 20% were a single table. So 90% of our business or data sets really didn't need a relational database. And we also figured out that we needed, or as an attribute, as an outcome of that, we basically said we needed to have a platform that was infinitely scalable with no performance and limitations at all. Because we knew we were growing fast, we're growing faster than most business out there, and we needed to respond. DynamoDB is what we launched and what we came up with. We launched that in 2012. And in parallel, the Dynamo paper also gave birth to basically NoSQL, right? So Cassandra was the outcome of that, and a bunch of other ones. So it spurred and created a category, created a new data structure for either non-tabular, non-relational data sets. Key now, now Dynamo is a tier 0 business for us. Excuse me. Runs all of AWS, pretty much everything from payments to inventory to our website. Excuse me. To our warehouses, to our scheduling systems. It really backs up the entire business. It scales infinitely, or we haven't hit any limits yet. Not yet. We may. And so it's not only is it performing at an immense scale, right? With consistent performance, sub-millisecond, single millisecond performance, no matter how much data you throw at it. I talked a little bit about the project and what we did with it. It's, the project itself was called Rolling Stone, but it really included a lot of little projects. And there's a typical model for AWS where we break really complex things into small, bitable chunks. And I think we finished it in 2018. We started way back when, but it took us probably 10 years to improve all the efficiencies or address all the challenges that we had with efficiency, scalability, performance, cost, et cetera. And I'm sure everything I just said, you guys are just thinking about it as well. By the way, I think I can see the room. How many folks are actually using DynamoDB today? All right, cool. 70, 80%. Great. Yeah, so it's one of our most popular databases. I'll say it, we have hundreds hundreds of thousands of customers today. It's material business to us. It's material to all of our customers, whether it's streaming, e-commerce, retail, automotive, across every industry. And they're seeing the same kind of improvements in their business and operational improvements, not only in terms of performance, but how they're able to respond to their customers. All right, when we talk about modernization, to date, you sort of start out with either some sort of lift and shift to a data set, but you, from an application perspective, you're addressing how you're building the app, what kind of tools you're using microservices, you're interacting with data on the fly, you're reducing latency by interacting on that data on the fly. But if you're still using a monolithic or some sort of relational database, and most of our customers are still doing that or have been doing that, and they're still doing it. And one of the reasons we have so many meetings this week is they're realizing that they haven't addressed the data side of the equation. And so you have to think about what kind of data, who is interacting with it, who is going to be using it, how, what kind of latency requirements does that data have, so you can actually put, or data model as well, so you can actually put it where it needs to be, as close to where it needs to be for that specific application. All right, so I kind of just said this, but you have to look at and attach the right data to the right application, to the right customer, to the right tool when it needs to get there. All right, and so to that, I'll introduce Dennis. He's the Director of Software Engineering at Fidelity. He's a great customer. He can talk for hours, so we're gonna have to control when he stops. There you go. Thank you.
Thank you very much. Hi, my name is Dennis Healy. I am a Director of Software Engineering at Fidelity Investments. I've been at Fidelity 13 years. I've been designing and implementing order management systems for over 28 years. For 8 years, I worked on our low latency routing system at Fidelity. I'm part of the team that is moving our order management system from the mainframe up into the cloud. Oops, a little too far. Nope. All right, so what is our order management system? Perhaps you might go to fidelity.com, or you want to buy a stock or sell a stock. You go in, you fill in your information, you press buy. That order will eventually go into our order management system. It has to be validated. It'll be persisted. It'll move into the routing system. And then we'll figure out where to send that to an execution venue, either a stock exchange or a broker-dealer, perhaps our internal crossing network. Eventually, that order will be acknowledged and then hopefully filled, and that'll come all the way back through our system into the back-end systems, and the client can see the results of that order, that trade. We divide our order management system, our OMS, I'm going to refer to as OMS going forward. We divide it into two halves, the order entry piece, that's kind of the validation and the persistence, and the order routing, that's where we figure out where we're going to send it. I represent a team of about 20 people that have been working on the order routing system in the cloud. Why did we do this? Like we just heard earlier, our access patterns are mostly key value pair. Additionally, employing managed services was very compelling to us. Not having to maintain database servers was a huge deal. We needed to be highly resilient. We have to be hot, multi-master. We needed to be able to continue processing orders even if we lost a region. Some of the orders I described come into the system, they're acknowledged and filled right away. That'd be a market order. That usually happens in less than half a second. We could get a limit order. And a limit order, if it's away from the market, that could sit in that system for minutes, hours, days, weeks, months. So that we need to be able to have that order and be able to act on it. And if it was processed in one region and that region goes down, we need to be able to have the client be able to act on that order, perhaps cancel it, replace it, maybe change the price of it if the market wasn't going his way. So we needed to be multi-region. Within any one region, we want to be a multi-availability zone. We can't have just one AZ go down and disrupt our order flow, disrupt the customer experience. While we're doing, so thus we went multi-region, of course, we went multi-AZ, Dynamo gives us that. We need to be able to keep order processing latencies low. Again, coming from my world where I was on bare metal, we used to measure these things in 1, 2, 3 milliseconds. It's a little bit higher up in the cloud, but we still need to be able to process millions of orders in less than a second. We needed to be able to scale up to meet market conditions. March of 2000 made it very clear to us that our current cloud strategy was not going to scale up. During that month, probably from March to July, we saw our max peak trading quintuple, 5 times. And that just, a lot of brokerages on the street had problems. They had outages. They went down. We did not. But the writing was on the wall. We were not going to be able to scale on-prem. So we changed our gears, and we decided we were going to go up to the public cloud. We put together a POC. This is just to go up to the public cloud in March of 2020. By October 4th of 2020, we were doing our first trades exclusively in the cloud. We immediately started performance testing that, trying to scale it. And that move was a lift and shift. So whatever servers that we use for database, or a NoSQL cluster that we were running, we just lifted that up and ran it on EC2s. Started performance testing it, and it wasn't scaling to what we knew we were going to need. So we started looking at DynamoDB, and we got all the benefits that we heard that would be coming as far as the multi-region, multi-availability zone, the low consistent latencies. We tried other NoSQL solutions that lift and shift, the on-prem one. When we started adding service to that cluster, we actually saw our latencies for processing an order. When I talk latencies, I'm talking about when the order comes in to when I send it out to the venue. On-prem, we were seeing that around 36 milliseconds. We went up into the cloud, I think it was around 45, maybe 50 milliseconds. But when we tried to scale it and really hit it with big performance testing, we ran into all sorts of limitations. So we added more service to the cluster. That's what you would do. That's how you scale up. Only as we added service to the cluster, I saw my latency start going from 50 to 100 to 250 milliseconds. So that solution was not working. We couldn't use that NoSQL solution. Other limitations that we ran into were max current connections, max concurrent transactions. So we needed to do something differently. And that's why we went to DynamoDB. What our architecture is we're running 2 separate copies of our entire system, 2 different regions. The application is entirely EKS. It's running in multi-region, hot. It's got the multi-availability zone, the EKS, all the pods. We chaos test this weekly. We knock down network availability to an availability zone. We knock down pods. We used chaos mesh to interfere, introduce blasts of network disruption. We've disrupted the databases that we interact with, not primarily for the order processing, but we interact with databases still for other things. With DynamoDB, we leveraged their global tables. So we didn't have to implement anything on replication or anything like that. Global tables automatically replicate. And so one of the things we would do is we would test what I was just telling you about. We would send flow through both regions, knock one region down. And the data would be where we would need it. Our system would detect that one of the regions was down, and throw a circuit breaker, start sending the flow, so not just new orders, the flow, when I say flow. I'm also talking about order cancels, or order replaces. Again, changing the order amount up or down. Another key component of this system, this multi-master system, is the fix engines. If anybody here, financial industry, is familiar with Fix, Fix is a TCP. Fix was started in the 1990s. It's the way trading is done, how institutions all send orders and executions to each other. It's a markup language but it's TCP. It's not a REST-based system or a web-based. It's a hard socket connection that stays up, and you need the heartbeat over it, and you need to detect when that goes down. It is serialized, so sequence numbers are maintained. TCP goes down, especially up in the cloud. We need to reestablish that connection. We need to resync sequence numbers. I'm sending you 100, you're sending me 101. You're only expecting 90, so I have to resend 90 through 100. And that's what the Fix protocol does, and we had to handle and solve that problem in the cloud. The other thing we do is not just disconnects and reconnects and resyncing, is what if the pod just goes away, or the server that pod is running on? Because again, this Fix engine is running in EKS completely. Well, we're running in Kubernetes, so the pod just spins up somewhere else, and it has to reestablish that connection. There are times when we test this weekly with our chaos testing where we fail over the whole thing. We push a button in our UI, and that shuts down one region, and because of our design, the other region lights up all those fixed sessions, reestablishes, resyncs the sequence numbers if it needs to. So that's the system that we ended up having, and Dynamo was a big part of that. So we get the low latencies. I don't have the graphs to show you. I'm going to use a lot of my hands, but that's what our latencies look like when we throw load at it. What did we accomplish? After we had done that trade, October 4th of 2020, we kept the system that we had going. The performance of it was sufficient as far as scalability goes. As long as some tidal wave didn't happen, we could handle it. But that's not how we work. That's not how we test. We tidal wave. We run as much as we can. We had our code rewritten, recompiled, going against DynamoDB exclusively for the trading data. That's orders, executions, and some other internal tables that we use. We had that up and running in 3 days. And then we started scaling it a bit to handle more and more throughput. And we were able to test 10 times the max of what we have ever perf tested. Not 10 times what we saw in production, 10 times what we've ever tested before. That's transactions per second 10 times, and total orders for the day 10 times. So we were quite happy we had a winner here. And it was March of this year, we did that POC and started retooling and testing. And our first trade this year, the POC was the previous year, March 25th was our first trades based against DynamoDB. This year, we haven't looked back. That very first slide that was up there today, this is my testimonial. When we have a problem on our order management system, the world stops. Project managers, developers, DevOps, support people, order room support, traders, stop what we're doing, we get on a phone call, Root cause, what happened, why did it happen? Is it going to happen again? What should we do? Are the customers whole? Sometimes these phone calls can take hours to work through all this stuff because we need to make sure we do it right. I am not overstating things when I say when we went to DynamoDB, I don't know the number, but way more than half of those phone calls stopped. Some of the phone calls that we would have is an order would take all of a sudden 10 seconds. Whoa, why did it take 10 seconds? Get on the phone call. Why did it take 10 seconds, Dennis? We'd have to dig through. Oh, was it hitting this database? Was it hitting our queuing system? Was it trying to make a REST call somewhere else? Was it most often, it was that NoSQL system. And it was just painful enough that we would have these phone calls. That immediately stopped. We don't have phone calls because Dynamo has failed us. We still have some of those phone calls. Other things can fail. But it's not because a pod went down. It's not because of DynamoDB. It's not because of any of the other managed services we do. Why do we continue to, I didn't mention it, sorry. In that architecture slide, I want to go back real quick because I don't have many slides, and you're all mine. Yeah, that was good enough, I'll go there. That architect, so our EKS pods, we're reading, writing DynamoDB exclusively. It's transactional as far as, they're not REST calls, this isn't a web app. Right, so an order goes through our system, there's a state to it. It goes a little bit more through our system. There's a state to it. Very asynchronous, these messages. From one system to another, it's an asynchronous queued call. And the fixed protocol is asynchronous. We send an order out with the fixed tags. It's another full duplex line. The acknowledgement may come back milliseconds later. It may come back a minute later. So we don't wait. We just keep sending down the line there. So that's our hit to Dynamo. What we do is, behind Dynamo, we have Lambdas subscribe to Dynamo event streams, and they write to an RDBMS. And of course, why do I do that? Originally, when I practiced this, I'll tell you later. So now I'm going to fast forward and tell you. Why do we continue to write to an RDBMS? Those of you who know Dynamo would probably know why. I know my boss, who was just out in the hallway, was asking me what I'm going to do about this. Some queries are complex. They just don't line up well with a NoSQL database. We've reduced that exposure to that kind of limitation to our GUI, which is really just for trade support, and for our end-of-day reporting. Like CAT report, if you're in the financial industry, our CAT reports come out of that. For now, we're going to continue to migrate. What are the lessons we learned? So one of the biggest things, I was just talking to somebody about an hour before here, take advantage of the TTL, time to live. Once that's set, and we deal with millions of orders or millions of records, not legacy system, but the system I had before, I'd have to chug through all those orders and say, is it closed? Is it finished? Am I done with it? Delete it. And I have to do that for everything, and not just the order, the executions for it, or other records that are associated with that. I'd have to evaluate and delete. In these days, when we're mostly doing market orders, we're limiting exposure, so we don't have as many orders that live over the day. We set the TTL. And I have a dashboard, DynamoDB dashboard that we built. And I can see overnight, so we create an order, we created all these records, we set the TTL. I'm not going to need this in 14 days. So we just set it, and then I look at my dashboard, and overnight, I see all the millions of records being deleted from 14 days prior. No code, no process has to be written, just works. Structure tables to support secondary GSIs. That's the answer to Lou's question. How do you query? You can't say select all from a table. Or you could, but it can be painful. So you structure secondary indexes to meet those queries so that they will be performant. It's okay for data to be redundant. Again, because NoSQL databases don't really support joins, they're not performant. So if you need a little bit of extra data, you just duplicate it. And there's nothing wrong with that. Some extra latency is worth it. What we saw when we went to Dynamo, because it is distributed in any one region, it's multi-availability, and it is replicated, we saw increases of about 1 to 2 milliseconds on a lot of our calls. In some cases, not every call. But that was worth it for the resiliency we've seen. I told you, we just don't see outages due to DynamoDB hiccups. And of course, the consistent latency. That 10 times the order flow that I was telling you about, latencies were just as low as they were before. Now, last time, I think I observed the performance testing 2 weeks ago Wednesday. So from tonight, 2 weeks ago, I want to say our latencies were down in the 60s, low 60s, which is even lower than it had been before. Well worth a little bit of extra data duplication, a little bit of extra, a couple of milliseconds for the resiliency and the scalability that we're seeing. Those latencies I told you when I was around 36 to 40 millis, I think I was running 40 pods of my big engines. We now run regularly over 100 and just blast, like I said, 10 times what we used to run through it. Leveraging lambdas for asynchronous processing, like that right behind. We do want the UI to catch up, and it does catch up within a second or two, but that's sufficient for what we're dealing with here. So anytime, and I'm looking at our code base, anytime we start peeling off threads and doing something asynchronously, that could be a lambda. And that could go serverless, so taking CPU load, taking main resources from the order processing, and putting it off onto the serverless. And one other thing that we learned is because the global tables are replicating, and the RDBMS also replicates, we'd end up with double the data everywhere if we didn't do something. And so at the Lambda level on those right-behinds, we filter out the remote site. So when a Lambda's processing and doing the right-behind, it's going to say, is this data from my side? Region 1. If it is, it'll send it down to the RDBMS. If it's not, then it just ignores it, because the other site will do it, and the RDBMS will replicate it. Somehow I missed one thing, and I forgot what it was. Yep, I did. And talk to me outside the hall, I'll remember it, or if we have questions here. At this point, I'd like to, another great example of how database modernization accelerates innovation comes from Reltio. Please welcome Manish Sood, Reltio CEO. He will tell us more about their journey.
Thank you. Go ahead. Well, thank you for sharing some of those great examples and the lessons learned. So our journey was a little different. At Reltio, we're providing a software as a service, multi-tenant platform for data unification. And we have been doing this since 2011. It is a product capability that we deliver to our customers. Every customer that we have across a variety of industries is trying to bring together information for customer data, product data, supplier data, because that drives the core part of their business, and they need to use it at operational scale across their entire enterprise. But when we started our journey, there were not that many capabilities available for us to bring together this functionality because we decided on day one that we were going to start our product journey by building out this capability, a SaaS multi-tenant platform on public cloud infrastructure for managing your core critical data that your business runs on. And as you can see from this slide, there are a lot of global brands, global customers across a variety of industries. But in 2011, we had to start our journey with a NoSQL database, which I'm sure a lot of you have used. And in that journey, what we discovered was that as we are trying to build out the product capabilities, as we are trying to scale, because this notion of more data, more applications, more silos is growing constantly, not only do each one of our customers need the ability to scale, but we as a company needed to scale across all of those customers that we were working with. And working with some of the previous capabilities of other NoSQL databases, we learned that provisioning additional capacity or capability was easier, but scaling those down wasn't. So every time you had to work with any kind of a higher throughput, higher performance, higher scale type of needs, you almost have to think about, what is the peak capacity that you're going to handle and provision for peak performance. And that, as a software as a service company that is trying to deliver a product, that has a direct impact and correlation with the margins that you're operating your business at. So, for us, as we were building out these capabilities and solving these complex challenges for our customers, we were trying to figure out how, at the same time, refine the backbone that we have created this capability on. And not only improve or optimize our own footprint, but at the same time, look at innovation that would help us deliver better results at every step of the way for our customers. Because none of these customers ever came to us and said, we want to manage less data, we want to run it at a slower speed. Everybody wants to go faster, and especially with the digital transformation type of initiatives that everybody has. And the landscape that we operate in, there are lots of different applications from which we take the data in order to stitch together this unified view of who your customers are, what products you're selling, which suppliers are you getting these products from, so that you can have that data available as a product, as an API, to consume in each and every one of your applications that you're working with. And this allows us to provide the solution to our customers where you can essentially manage any type of data domain that you will see. Now, as you can imagine, after running, every other flavor of NoSQL databases, and for us, Cassandra was one of the big NoSQL data stores that we started with, we had, over a period of 10 years, built a significant footprint in our cloud offering, where all of this data is getting collated, unified, and then being provided as a constantly enriched and cleansed capability back to the customers as an API. And this API has to be low latency, has to continue to scale through the weeks, through the various peaks and valleys of their performance requirements that they will see. And that's a significant footprint that now, over a period of 10 years, we had created inside our cloud offering. So if you think about our journey, we started with a cloud-agnostic NoSQL database. Obviously, if you're a product company and you're creating capabilities that can run on every cloud, you're thinking, it's a great thing to have a cloud-agnostic database that you can use across every flavor of it. But how do you balance that with the need for performance and scale that you want, so that you can scale up, scale down dynamically? You can also optimize your margins that you're working with. So the challenge that we posed in working with the DynamoDB team was that, not only do we want to optimize our current footprint, but we want to have a lower operating cost for the entire footprint that we have as we migrate from our existing footprint over to DynamoDB. And this is for the entire platform that we had, all of the data over the course of 10 years that was built up. And some of the things that we talked about, which were infinite scalability, the ability to look at better margin performance. All of these were the inputs into the requirements that we shared with the DynamoDB team. And before I go into the details of how we performed against those requirements, the other additional thing that came up as a part of this was that each one of our customers wants the capabilities that we provide to be tier 0 capabilities for their business, because they're tying order processing, to the customer data that is being created inside Reltio, or any kind of product information that is available inside Reltio. In fact, one of the customers that we work with is Subway. When you order a Subway sandwich through their digital experience, before your sandwich order is completed, your profile is being looked up from Reltio or is being aggregated inside Reltio so that it can be available for that hyper-personalized experience. And that round trip has to be completed in milliseconds. And if that fails, then the ability to order sandwiches goes down, which may sound trivial, but at the same time, that is how they are defining the digital experience that they're trying to rewire into their entire business process and flow. So the capability that we provide had to be available 24/7. We were previously delivering a 99.95 SLA, but customers wanted a higher SLA, uptime SLA from us. So starting with what we had as the footprint, which was a massive footprint of Cassandra clusters, which limited our ability to scale up and dynamically scale down, or think about the amount of maintenance that is required when you have an extremely large footprint at a global scale, or what happens if you are provisioning new clusters, adding new nodes. How much time does it take for the data to settle down with existing capacity and additional nodes being added? Or when you're pulling nodes down, how much time does it take again for it to balance across all the nodes? All of these were challenges for us. And God forbid, if somebody makes a provisioning mistake, you end up with an absolute disaster on your hands because you have to recover from it, and that takes time, essentially impacting the SLAs or the availability of your solution. And this is where, as we made the transition to Dynamo, we were able to not only get a highly resilient database available across multiple regions, 3-zone architecture, that's great. But now you need multi-region type of capabilities. Having that available where you don't have to spend the time to provision it, to bring it up, and it's something that you can drive with infrastructure as code, was extremely appealing to us. The automated real-time scaling and scaling in both directions, up and down, again, allowed us to handle the Black Fridays or the Cyber Monday type of peak loads without provisioning for peak capacity at all times. And just the fact that it is out-of-the-box multi-regional capabilities where you're depending on the global table type of functionality, and even when we went through the discussions with our own engineering and product teams, the fact that we were now talking about being able to check a box that allows us to have global tables across regions was extremely compelling without having to go through the intense, heavy lift that we would have under other circumstances. And then, the simplicity of provisioning and maintenance, essentially eliminating a lot of the maintenance overhead. In our case, as we think about our security posture, our ability to keep everything in our top to bottom stack up to date, we were patching various servers, various nodes, and that was an overhead to stay up to speed with everything that we needed to bring it up to. But now, all of that gets bundled into an offering that's already taking care of some of these types of capabilities. And at the same time, the new functionality, how it unlocked more capabilities that we could introduce into our product itself. So for example, every customer that we work with, we are running this as a software as a service capability where the Reltio platform is managed inside our perimeter. All of the data gets aggregated and unified inside that perimeter. But customers came to us and said that they would like to bring their own encryption keys for the tenants that we are provisioning for them. And through our APIs, through all of the capabilities that they're managing inside Reltio, they would like to use this notion of their control over the data encryption. So we leveraged the capabilities, the bring your own key type of capabilities from DynamoDB to create a product offering on top of the Reltio platform that is now fully integrated with the KMS, and a customer can come in through their own perimeter. They can manage and use the keys that they want inside our DynamoDB instances. So that became a feature add based on the base capabilities provided by DynamoDB in this particular area. And in order to give you a sense of size and scale, overall Reltio, as we take in data from multiple sources, is managing about close to 40 billion API calls on an annual basis. It's about 8.3 billion consolidated profiles. These are records for people, organizations, product, locations. So think of customer data, supplier data, product data, those types of things that are being managed as unified profiles inside Reltio. We have created an entity graph type of a model that sits inside DynamoDB, which then allows us to manage the linkage across various types of these entities or data domains. And we have users who are accessing not just our API, but some of the UI capabilities from across 140 plus different countries across the globe. And all of this is running with DynamoDB as our primary data store, which essentially translates into about 67 terabytes of data in Dynamo, about 86 million average reads per day, about 11.2 million average writes per day. And we just went through the Black Friday type of scale, and we had about close to on Black Friday, close to 6.5 million peak reads per hour, and about close to 2 million writes per hour during that peak load. And all of this without having to sit there and do anything about provisioning any of the additional capacity. All of this was managed as a part of the code that we have developed in order to make sure that we can use the scale up and scale down type of capabilities without changing any of the latencies in the process for the type of traffic that we are trying to service through this overall solution. And this has been a game changer for us, because this now allows us at a lower cost of goods to deliver better capabilities at a faster speed, higher scale, greater throughput overall in this process. And we went through this transition where we, given the operational needs of our customers, we did this transition from Cassandra over to DynamoDB without bringing down our system. So it was zero downtime, zero impact to the customers. Yes, we had to run the two systems in parallel for a little bit of duration, but overall, this was with the help of the DynamoDB team that we were able to design the overall migration path in this manner with them. And that was also one of the learnings in the process, that getting the team involved, the DynamoDB team involved, to work closely on the entire design process with us was an extremely critical part of the overall journey that we went through. And this now gives us a new foundation that we can continue to innovate with, because our business is to create the capabilities that ride on top of this, instead of having to spend our time below the surface of this database management and the capabilities that need to be added or unlocked from there. And that's, going back to the original thesis of when we started Reltio, we said, we're going to create this software as a service capability on public cloud infrastructure, because that is the layer cake of innovation that we can ride at a faster speed and scale in order to create new product offerings that we can bring to market. And that's what we are proving out with the migration to capabilities like DynamoDB in this overall journey. Some of the challenges or lessons learned, there were some delays in our migration process, but those delays were largely, some unanticipated challenges with how the data had been, malformed inside our Cassandra clusters or the column families, and we had to run some remedial processes to fix that overall data before moving it over, which was also a good thing for us, because that surfaced some of the gaps we had in our existing solution. We were able to go back and fix those things as we moved to a cleaner state with the DynamoDB foundation. And again, going back to realization of some of the benefits on the COGS side, where the overall footprint that we were managing with Cassandra, now we were able to manage that at a lower cost, and that was part of the overall decision. But any delay in the migration process delayed our ability to start realizing those cost benefits out of it. So, again, something that, if we were doing it again, we would think about that migration process and shrink it down further to a narrower window so that we can get to the end point of realizing the value and the benefit out of the new backbone that we created with DynamoDB. And, with this, again, our journey in this started in the cloud with a NoSQL database, but even in that process, we learned along the way that there were lots of new additional capabilities, and the pace at which we could unlock new features in our own product, we could do that with the layer cake of innovation that sits in capabilities like DynamoDB that we have been able to leverage from Amazon. And that allows us to deliver a real-time operational capability for master data management, for data unification, for concepts like Customer 360 or data as a product type of capabilities that you're starting to hear about in the data management landscape. So with that, I'll hand it over to Vladimir to close out the session. Thank you.
All right, thank you. I know we're up against the clock here, so I'll talk fast. So first of all, thank you to Dennis and Manish. It's always nice to hear this from our customers, right? We can talk about it all day long, but when our customers tell you, let me just keep going here, how they've actually been able to develop a new class of applications, deliver a completely new experience and/or customer experience and/or features to those customers quickly, and obviously save money in the process, improve operational efficiencies, et cetera, resonates a little bit more than me telling you. So thank you so much. I hope this is not news to you guys and everybody that's here. We talked about two different ways to actually start the migration, right? There's a lift and shift, but if you're sort of a cloud native company, you can figure out how to improve, how to introduce net new data sets or net new databases depending on what you're trying to build. So there's no right and wrong way of doing it, but typically what we see enterprises doing is they start with a lift and shift, right? They have a legacy database. They just put in EC2. They figure out that they run into the same challenges. They start looking for a managed service. They start and look at RDS and Aurora. So that's pretty typical, right? If you need a relational service, and by the way, there's a place for every kind of, let's just say, data set or data type within an application. Like if you look at Amazon.com, there's a relational database. We probably have 200 services on every Amazon.com page. We have a search capability built into the search tool. We have relational for transactional. We have Dynamo. We have Neptune for relational or connecting various entities in that page, right? So there's a need for every kind of data set and every kind of data type within an application or for a customer use case. The next thing that we see is once you start moving into a managed relational database, you realize that it doesn't suit all use cases and obviously all applications, back to what we talked about. And you start looking for, hey, how can I improve the latency? How can I improve scalability? And you start introducing key value or dynamos, right? We have Dynamo, we have document, we have key spaces. If you're managing, if you have a big Cassandra footprint, right? And you want to maintain a lot of the same APIs and the skill set that you have managing that Cassandra database, you can just move it over to key spaces and start introducing Dynamo over time, right? If you want to use graph, if you want to look at entities and you want to get those results super quick, you introduce Neptune. But it has to be for the right use case. All right, we have a booth. If anybody wants to meet after the session, we'll be happy. Thank you, everybody, for making the time to come here late in the afternoon.